Hey, this is Mauricio Salazar and I'm from Campus Eugenio Garzazada.
Hi, my name is Rogelio and I'm from Tech Campus Garzazada.
Hi, my name is Jose Adrián Rodríguez Flores and I come from Campus Eugenio Garzazada.
Hi, my name is Diana Cortez and my name is Regina Leal and we're from Campus Santa Catarina and this is our project that is the Chernobyl project.
And we will talk about exponential growth and decay.
We're also going to talk about the nuclear energy and reactions and about a catastrophic problem that passed a long time ago.
On April 26, 1986, the worst nuclear accident occurred at the Chernobyl nuclear power plant in Ukraine, which was part of the Soviet Union. There was a big explosion which released radioactive particles that spread throughout the atmosphere of Western Europe and killed 31 people. The toxic cloud began spreading throughout Asia, Europe, and even the US. Many people were poisoned, and the long-term effects are the cause of cancer, mutations, and deformities. Another example of exponential growth was the Fukushima nuclear disaster in 2011, where a tsunami caused by an earthquake disabled the cooling and power supply in 3 reactors of the Fukushima Daiichi power plant. The 3 Mile Island accident that happened on March 28, 1979 in Pennsylvania, USA is yet another example of exponential growth caused by a malfunction in the secondary section of the plant.
Well, my question is, why hasn't it been possible to contain the nuclear energy and substances generated by the nuclear reactors explosion in Chernobyl 1986? Well, the answer is because it was a flow reactor that was operated with inadequately trained personnel, like they weren't trained correctly to manage that machines. The steam explosion fire releases at least 5% of the radioactive reactor core in the atmosphere and downwind. That's why basically it explodes.
My question is, what is that makes the nuclear energy to be so dangerous? And what we figure out and what we research was that the nuclear energy is dangerous because a minor malfunction could make a whole power plant explode, and it is a radioactive waste that pollutes the environment, causing a negative effect on health, in us, in plants, in animals, and it also grows exponentially, making it the most impossible to contain.
Why is it said that a nuclear reaction generates an exponential growth in the atoms? In this case, a nuclear chain reaction which generates a lot of times more energy, which are bigger than a chemical reaction. This is when radiation or energy is exerted into the atom, which then is released in an excess, which then releases an excess of nucleons, which will make more atoms. So we will generate this exponential growth in the amount of atoms that there is in the whole number.
Yes, the radioactive materials can be dissolved, however not all. It would take at least 320,265 years for at least there to be only 0.001 quantities of radioactive material.
Hello, I'm going to be teaching you about the exponential functions, and we're going to start learning about the exponential function graph of the growth. And we start like this. So here the key point is we're going to 0, 1. We're gonna start by plotting the equation that is of the basic graph, and the equation is gonna be y equals b to the x power, where the b is a number and the x is a variable. The basic graph, as we're told, starts with the points of 0, 1, So we're gonna put it here, 0,1. And then, as we know have an asymptote line, it's gonna be 0. So here we're gonna put asymptote. It's gonna be y equals 0. And the last thing we're gonna see is the range and the domain. Range. And the domain is gonna be all real numbers, or it can be negative infinity to infinity, or all real numbers. And the range is gonna be from 0, because it's where your point is, to infinity. And the asymptote, it's 0, so we're just gonna put here the asymptote. And now it's time to graph. So if you have your point here, the basic graph tells us that it's gonna be upward like this, and very close to the x-axis, but it's not touching it, but it's very close. Here you can see that we have the basic graph, and this is what we call the growth, and we're now gonna proceed with that decay. In that decay, you have your basic function here, and instead of having y equals b to the x power, we're gonna have y equals b to the negative x power. And this negative, what it's making your graph look like from here, it's gonna pass on like this. And it's a reflection on the y-axis. So we're gonna put here y-axis. Your key point stays the same, but the only thing that changes is the line. So we're gonna transfer it from here, like I explained to you, that it's a reflection on the y-axis. It's gonna be like this. Again, it's very close to the x-axis, but it's not touching it. Here you can see that the key point stays the same, because it's 0,1. And the asymptote stays the same too in the x-axis, because again, it's not touching, but it's very close to it. And the range and domain stay the same, because the range is declaring that it's 0 to infinity, and here it's 0 to infinity, and the domain, it's all the x-axis.
Some of the implications of using nuclear energy is that we use this energy for electricity, medicine, agriculture, and for research such as biology or chemistry. Nuclear energy is not clean. It's not a clean energy, as it damages the environment, and it is kind of a poison for the earth if it has a breakdown, as it happened in Chernobyl. And lastly, in Mexico there is a nuclear plant. It's located in Veracruz. It's called Laguna Verde. It generates 4.5% of the energy that Mexico uses. I don't think it's safe because it generates a small amount of energy, which we don't really need that 4.5% from that nuclear plant. I think we could use more cleaner or more green energy, but having this nuclear plant also makes Mexico look more powerful, and it makes it look better.
So yes, the Chernobyl disaster could have been prevented by using proper design technology and properly trained operators. There was no way that the radiation could be stopped after the explosion due to exponential growth, and the radioactive pollution may have reached Mexico because studies show that it reached the United States, and Mexico is a neighbor. So the Chernobyl accident negatively affected the environment by contaminating water bodies, plants and forests, urban areas, and agricultural areas. So, what are the environmental consequences in a global scale of other nuclear disasters and use of nuclear weapons? Well, nuclear disasters such as the Chernobyl accident and the use of nuclear weapons like the bombings in Japan during World War II have enormous impacts in the environment at a global scale. They affect the atmosphere, hydrosphere, biosphere, and causing damage up to a 100-kilometer radius. The worst part is that the radiation lingers for decades, causing a variety of diseases like cancer, genetic damage, and mutations. The high levels of radiation not only affect humans, but also water, plants, and animals. The radiation is spread rapidly due to the process like food chains and water cycle. It also causes changes in the climate, blocking sunlight and decreasing rainfall. If the use of nuclear weapons becomes regular, it would destroy life as we know it. The consequences are far too severe for the environment and for the living species. The world can't afford nuclear explosions, and a solution to this problem could be to ban all nuclear weapons, since they affect everyone who lives on Earth, not only the enemy. And to avoid nuclear disasters, drastic safety and maintenance measures should be imposed in all nuclear plants so that less accidents happen. And lastly, how did we feel about working like this? Well, it was definitely different working like this. It was enriching and a mind-opening experience. And thanks to the many advances in technology, it was not difficult to work with people from another campus. What we liked the most about working like this is that there were no distractions while working, and it was more efficient and productive.
Era lo bonito del mar cuando estás a mi lado, no hay otro lugar.